This video is sponsored by MOVA Globes. From discovering a record-breaking black hole lurking in our cosmic backyard, to finding compelling evidence of oceans of liquid water beneath Mars, 2024 was a monumental year in space. So, as the year comes to an end, let's have a look at 7 of the most exciting space discoveries that changed our understanding of the universe. In the far reaches of our solar system, beyond the orbit of Neptune, something unusual is happening. A mysterious force is pushing around icy objects, and clusters of these objects have unusual orbits that can't be explained by the known planets alone. Scientists think this could be caused by a massive, hidden planet, often called Planet 9. First suggested in 2016, this potential new planet has fascinated astronomers everywhere. Some researchers believe it might have been a rogue planet captured by our sun's gravity, while others think it could have formed from the same disk of gas and dust as the other planets. If Planet 9 exists, it is believed to be 10 times more massive than Earth and orbit the Sun at a distance of 400 to 800 astronomical units, which is 400 to 800 times the distance between Earth and the Sun. Astronomers have been eagerly hunting for clues, using powerful telescopes and advanced computer models to track its influence. After years of watching the sky, solving mathematical equations, and running complex computer simulations, they now have the strongest evidence yet that Planet 9 really exists. Far out beyond Neptune, there are lots of small, icy objects floating in space. Over many years, Neptune's strong gravitational pull can shake up their paths. Some of these objects might even get flung out of the solar system altogether. These objects are a part of what we call trans-Neptunian objects, or TNOs, and they can sometimes get nudged into orbits that cross paths with Neptune. To understand how these objects move, a research team created computer models to simulate the distant part of our solar system, including an area called the inner Oort cloud. They chose TNOs with perihelia greater than 30 AU and semi-major axes ranging from 100 to 5,000 AU, resulting in a simulation of 2,000 total particles. The research team ran 2 sets of simulations, one including the hypothesized Planet 9 in its predicted location and another one without Planet 9. Their findings showed that Planet 9 could really mix things up. It might change the way these icy objects orbit, making their paths more stretched or tilted. With Planet 9 in the picture, these objects' paths are likely to cross Neptune's orbit more evenly and farther out into space. Without Planet 9, these crossings mostly happen much closer to Neptune and aren't as spread out. The comparison strongly supported the model, including Planet 9, showing a much higher likelihood of 0.41 compared to just 0.0034 for the model without Planet 9. This substantial difference in probabilities indicates that the model with Planet 9 aligns more closely with the observed behaviors of TNOs, suggesting a significant role for Planet 9 in shaping their orbits. Hunting for Planet 9 is quite challenging. There are 3 main problems. First, it is incredibly distant, believed to be 10 to 20 times farther from Earth than Pluto. This vast distance means it receives very little sunlight, rendering it nearly invisible against the starry sky, making it difficult for telescopes to detect. Second, Planet 9 is thought to have a highly elliptical orbit. This would cause it to spend much of its time in the outermost regions of its orbit, where it's even darker and fainter. Third, the potential area where Planet 9 could be located spans a vast region of the sky. This requires astronomers to conduct extensive and meticulous scans, often needing to recheck and verify observations multiple times to ensure no possible sightings are overlooked. Planet 9 may still be a mystery, hidden far beyond Neptune, but you don't have to venture that far to experience the wonder of the cosmos. MOVA Globes lets you bring that same wonder of awe right on your desk. Powered by ambient light and hidden magnets, they spin silently, creating a serene and mesmerizing display in your home or workplace. No cords, no batteries, just a charming display of science on your desk. MOVA globes come in over 40 captivating designs, including an outer space collection that features planets, moons, asteroids, and constellations. It's a perfect way to keep the wonder of space within reach every day. And for viewers of this channel, I've arranged a special offer. Use the code SOTU at movaglobes.com to get 10% off on 6-inch and 8.5-inch MOVA globes. So check out the link in the description and bring a piece of the cosmos home. One of the most intriguing astronomical discoveries in 2024 was that of Gaia BH3, a stellar mass black hole with a mass 33 times that of the Sun, making it the largest stellar mass black hole found in our galaxy to date. Located about 1,900 light-years away, it is also the second nearest black hole to Earth ever discovered. This finding was made through data collection over 11 years by the Gaia mission, which is primarily focused on creating a 3D map of the galaxy. Gaia does not detect black holes directly, but can infer their presence by observing the motion of stars. In the case of Gaia BH3, the mission detected an unusual wobbling in the movement of a star, caused by the gravitational pull of a massive, invisible companion, presumed to be a black hole due to its significant mass. In analyzing the movement, distance, and position of the star relative to the system's center of mass, astronomers determined the invisible object's mass to be 32.7 solar masses. This massive figure surpasses the theoretical maximum mass for neutron stars, confirming the presence of a black hole. This means that Gaia BH3 is a binary system, where a Sun-like star orbits a massive stellar mass black hole. Before the Gaia mission, no dormant black holes had been discovered. Gaia, however, has successfully identified several, with Gaia BH1 and Gaia BH2 found in the past 2 years, and Gaia BH3 more recently. Among those discoveries, Gaia BH3 is particularly notable for its distinct characteristics. An interesting aspect of Gaia BH3 is its orbit compared to earlier finds. This animation compares the orbits of the black holes and their companion stars, placing these orbits in context by projecting them onto a scale with the solar system and using the Sun as the reference point. This visualization clearly shows that the star in the Gaia BH3 system is in a much wider orbit around their mutual center of mass than those in the Gaia BH1 and BH2 systems. The discovery of Gaia BH3 is a significant milestone in astronomy, primarily because it hosts the most massive stellar black hole ever identified in the Milky Way galaxy. Also, its mass places it within the range of black holes typically detected through gravitational waves, bridging the gap between the black holes detected through different methods. However, this discovery has raised 2 critical questions. How did such a wide binary system form? And how did the black hole come into existence? It's hard to explain how this black hole formed because it's far from its companion star. This large gap doesn't fit our current understanding of how black holes form, especially if the black hole came from a massive star, about 150 times the mass of our Sun. Furthermore, the system exhibits a retrograde orbit, suggesting it moves in the opposite direction compared to most stars in our galaxy. This unusual movement might indicate that Gaia BH3 originated from a merger event, possibly with a globular cluster, which is a tightly packed group of stars. There's also a possibility that the observed star orbits not one, but a pair of black holes, making Gaia BH3 potentially the most exotic 3-body system in the universe. The most exciting space news of 2024 came from our neighboring planet. After analyzing years of seismic data from the InSight lander on the Red Planet, scientists concluded that there's a hidden ocean of liquid water 11 to 20 kilometers or 7 to 13 miles beneath the surface of the planet. This reservoir is so large that it could cover the entire planet with up to a depth of 1 to 2 meters, or about a mile. Although it's too deep for future astronauts to reach, this discovery has solved a long-standing mystery about Mars. Where did all the water go? Mars wasn't always the dusty, barren world it is today. Over decades of exploration, we have found plenty of evidence that billions of years ago, Mars was a very different place. It had a thicker atmosphere and a warmer climate, allowing liquid water to flow across its surface. However, unlike Earth, Mars lost its magnetic field quite early in its history. With the magnetic field gone, Mars's atmosphere was left vulnerable to the persistent solar wind. Over time, this solar wind stripped away much of the atmosphere, causing the atmospheric pressure to drop significantly. As the atmosphere thinned, it became increasingly difficult for liquid water to exist on the surface. Water that might have once been present in liquid form began to evaporate and escape into space. The thinning atmosphere also led to a weakened greenhouse effect, resulting in a sharp drop in temperature. Mars transitioned from a warm and wet environment to the cold, dry world we see today. As the planet cooled, any remaining liquid water froze, becoming surface ice or permafrost hidden beneath the surface. However, according to our theories, even after accounting for the water lost to space, Mars should still have a significant amount of water. The frozen water in the polar ice caps wasn't nearly enough to account for it all. To locate this hidden Martian water, the researchers used data collected by the InSight lander. Over its mission, InSight detected over 1,300 Mars quakes, providing crucial seismic data for this discovery. Scientists applied a mathematical model of rock physics similar to those used on Earth to map underground aquifers and oil fields. The model revealed that the seismic data was best explained if, deep below the surface of Mars, there existed a layer of fractured igneous rock with its cracks filled with liquid water. Igneous rocks are formed from the cooling and solidification of molten rock material, either magma below the Earth's surface or lava on the Earth's surface. This process occurs in various settings, such as beneath volcanoes or as lava flows after volcanic eruptions. As igneous rocks cool and solidify, they can develop fractures and cracks. These fractures can create pathways for water to flow through the rock and be stored in the spaces between the cracks. Over time, these cracks can widen due to processes like weathering, allowing even more water to seep in. While igneous rocks are not typically the most porous or water-retaining type, they can still hold water under certain conditions. Although the presence of water does not guarantee life, it enhances the prospect that Mars could have once supported life forms, possibly in these subterranean waters. After decades of hunting, astronomers finally discovered a planet around Barnard's star, a red dwarf about 6 light-years away. Named Barnard B, this sub-Earth exoplanet is among the smallest detected, with a mass about half that of Venus, making it one of the few known exoplanets smaller than Earth. Barnard's star holds a unique place in our cosmic neighborhood. While Proxima Centauri, part of the Alpha Centauri triple star system, is technically the nearest star, Barnard's star stands out as the closest single star to our solar system. Despite its proximity and longevity, its low luminosity and cool temperature make it difficult to observe with the naked eye. Yet, its remarkable stability and fast movement across the sky make it an ideal candidate for exoplanet exploration. The star's motion helps detect gravitational pulls from orbiting planets, particularly smaller, rocky ones that are hard to find. The discovery of Barnard B was made using the radial velocity method, which detects tiny wobbles in the star's motion caused by the gravitational pull of an orbiting planet. This technique revealed a planet that orbits the star at a distance that's just 2.2% the distance between the Earth and the Sun. Remarkably, a year on Barnard B lasts just over 3.1 Earth days. The small size and close orbit of this planet suggest it is likely a rocky world. However, its extreme conditions make it far from Earth-like or habitable. The equilibrium temperature is estimated to be about 400 Kelvin. This discovery is important because it shows that even low-mass, close-orbiting planets can be detected around a faint nearby star like Barnard's star, adding valuable knowledge about its potential planetary system. There's a big crisis in cosmology, and this image taken by the Webb telescope confirms it. It shows galaxy cluster G165 acting as a massive gravitational lens, bending and magnifying light from distant objects behind it. But something surprising caught astronomers' attention in this image. 3 mysterious dots of light that weren't visible in previous Hubble images from 2015. These 3 points of light, now clearly visible in the Webb images, turned out to be a Type 1a supernova in a distant background galaxy. Named Supernova Hope, this exploding star has been gravitationally lensed by the cluster G165. What we see are not 3 separate supernovae, but multiple images of the same supernova, whose light has traveled along 3 different paths, bent by the mass of G165, lying between us and the distant galaxy. This is a stunning example of gravitational lensing, where light from a background object is bent by the gravity of a massive foreground object, resulting in multiple magnified images of the same event. What makes Hope especially significant is that it is now the most distant Type 1a supernova ever observed. Type 1a supernovae serve as standard candles in cosmology, objects with known intrinsic brightness, allowing astronomers to accurately measure distances across the universe. These measurements are key to determining the Hubble constant, the rate at which the universe is expanding. However, there's a growing tension in cosmology. Webb's observation of this supernova has helped astronomers calculate a Hubble constant of 75.4 kilometers per second per megaparsec. This value, derived from the local universe, is in conflict with the Hubble constant, measured from the early universe, using data from the cosmic microwave background, which gives a lower value. This discrepancy has led to the so-called Hubble tension, suggesting that there might be something fundamental missing in our understanding of the universe's expansion. Supernova Hope represents the tip of the iceberg. With Webb's ability to observe distant supernovae, scientists anticipate uncovering more ancient stellar explosions that could deepen our understanding of the universe's infancy and possibly resolve this tension in cosmology. In 2024, combining data from the James Webb Space Telescope and the Chandra X-ray Observatory, astronomers discovered a record-breaking black hole that's consuming matter 4 times the theoretical limit, named LID 568. This black hole is located in a dwarf galaxy that existed just 1.5 billion years after the Big Bang. LID 568 is notable for its extraordinary accretion rate, consuming material at over 40 times the theoretical Eddington limit. The Eddington limit represents the maximum rate at which a black hole can absorb matter while maintaining a balance between gravitational pull and outward pressure from emitted light. This extreme feeding behavior raises important questions about how such black holes could achieve significant mass so quickly in cosmic history. The implications of this discovery extend to our understanding of black hole formation theories. Current models suggest that supermassive black holes could form from smaller seeds, either through the remnants of the first stars, the light seeds, or from direct gas cloud collapses, the heavy seeds. The rapid mass growth observed in LID 568 suggests that a significant portion of its mass may have been acquired during a single episode of intense feeding, regardless of its origin as a light or heavy seed. In 2024, astronomers analyzed the largest asteroid sample ever collected, uncovering some exciting surprises. This precious sample comes from Bennu, an asteroid drifting through our solar system. Bennu is like a time capsule from around 4.6 billion years ago, holding within it the untouched history of the early solar system. What makes Bennu so special is that it contains the very materials that were present when planets like Earth were first forming. 4 intriguing things were discovered in the Bennu sample. The first was the presence of volatile compounds, suggesting that Bennu didn't form in the asteroid belt between Mars and Jupiter. Instead, its origins likely lie much farther from the Sun, perhaps near or beyond Neptune. The next fascinating thing is that the sample from Bennu is rich in clays and minerals that show clear signs of having been changed by liquid water. Some of this water evaporated, leaving behind salts, which suggests that Bennu's parent body once had a warm, water-filled environment. Based on the findings, Bennu's original body was likely at least 6 miles wide, possibly even bigger. The third was the discovery of phosphates in the Bennu sample. Similar phosphorus compounds had been found in the warm, liquid oceans beneath the icy crust of Saturn's moon. This again hints that Bennu could be a fragment of an ancient ocean world that might have once contained some of the essential ingredients for life. Its parent body also contains various organic compounds, including amino acids, which are critical building blocks of life. Among these, researchers have found uracil and thymine, key components of RNA and DNA, the molecules essential for life. What's even more fascinating is that some of these organic compounds might have formed in the interstellar medium, long before they were delivered to Earth by asteroids. While the Bennu sample doesn't directly explain how life began, it offers important clues that could help scientists connect the dots between simple chemistry and the complex biology that led to life. Beyond the origins of water and life, Bennu holds clues about the formation of the Sun and the entire solar system. The asteroid sample contains pre-solar grains, tiny particles that existed before the Sun was even born. These ancient grains offer a rare glimpse into the processes that filled the early solar system with the essential ingredients needed to form planets and, eventually, life. Some of these grains are thought to have come from aging stars, while others could be the remains of supernova explosions. This discovery supports the idea that our solar system was enriched by the remnants of various types of stars, whose deaths contributed to the formation of planets and organic matter. It echoes Carl Sagan's profound words, "We are made of star stuff." The very elements that form planets and life itself were forged in the hearts of dying stars, reminding us of our cosmic origins. So thanks for watching, and I wish everyone a Happy New Year. As we step into 2025, it's the perfect time to bring the wonders of the cosmos into your life. Check out the link in the description for MOVA globes and bring a piece of the universe to your home.